ಶುಭೋದಯ. ನಾನು ಸವಿತಾ ಸ್ವಾಮಿ, ಲೆಕ್ಚರರ್, ಗವರ್ಮೆಂಟ್ ಪಾಲಿಟೆಕ್ನಿಕ್ ತುಮಕೂರು. ನಾನೀಗಾಗಲೇ 3 ಸೆಷನ್ ಅಲ್ಲಿ ಅಂದ್ರೆ ಸೆಷನ್ ನಂಬರ್ 25, 26, 27 ನಲ್ಲಿ ಟ್ರೀಟ್ಮೆಂಟ್ ಆಫ್ ವಾಟರ್ ಬಗ್ಗೆ ಮಾತಾಡಿದ್ದೀನಿ. ಅಂದ್ರೆ ಫಿಲ್ಟ್ರೇಷನ್ ಆಫ್ ವಾಟರ್ ಇಂದ ಸ್ಟಾರ್ಟ್ ಮಾಡಿ ಫಿಲ್ಟ್ರೇಷನ್ ಬಗ್ಗೆ ಹೇಳಿದ್ದೀನಿ, ಹಾಗೇನೆ ಡಿಸ್ಇನ್ಫೆಕ್ಷನ್ ಬಗ್ಗೆ ಹೇಳಿದ್ದೀನಿ. ಕ್ಲೋರಿನೇಷನ್ ಸ್ಟಾರ್ಟ್ ಮಾಡಿದ್ದೆ ಇನ್ ಮೈ ಪ್ರೀವಿಯಸ್ ಸೆಷನ್ ನಂಬರ್ 27. ಅದನ್ನ ಈಗ ಕಂಟಿನ್ಯೂ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. ಪ್ರೀವಿಯಸ್ ಕ್ಲಾಸ್ ಅಲ್ಲಿ ಕ್ಲೋರಿನೇಷನ್ ಅಂದ್ರೆ ಏನು, ವಾಟ್ ಇಸ್ ಮೆಂಟ್ ಬೈ ಕ್ಲೋರಿನೇಷನ್, ಆಮೇಲೆ ವಾಟ್ ಆರ್ ದ ರಿಕ್ವೈರ್ಮೆಂಟ್ಸ್ ಆಫ್ ಗುಡ್ ಡಿಸ್ಇನ್ಫೆಕ್ಟೆಂಟ್ ಅಂದ್ರೆ ಕ್ಲೋರಿನ್, ದೆನ್ ವಾಟ್ are the precautions to be taken while using chlorine. ಇದ್ರ ಬಗ್ಗೆ ನಾವು ಪ್ರೀವಿಯಸ್ ಕ್ಲಾಸ್ ಅಲ್ಲಿ ನಾವು ತಿಳ್ಕೊಂಡಿದ್ವಿ. ಈ ಕ್ಲಾಸ್ ಅಲ್ಲಿ we are studying about the residual chlorine and chlorine demand. I mean, there are two important terms, out of which one I have explained already in the previous class. I have talked about the residual chlorine. Anyway, coming to this class, we are mainly dealing with the chlorination part itself. Let us study about the residual chlorine and chlorine demand in detail. When chlorine is applied, you might have been studied about when the chlorine is applied after the treatment. I mean to say, after filtration we are going for disinfection. In the disinfection part, one of the methods of, chemical methods of disinfection of water is this chlorination. Okay, that is the first method we are dealing with. So coming in detail with the chlorination, we anyway know about how the chlorine is applied, why the chlorine is applied, and now we are dealing with the terms such as residual chlorine and chlorine demand. When chlorine is applied in water, some of it is in the sense, some of the chlorine is consumed in killing the pathogens. The term already I have explained. Some react inorganic and organic substances, and the balance is detected as residual chlorine. Already I have told you why the term residual chlorine is so much important, because it should avoid the recontamination of water. That's why residual chlorine should be there. And what amount, that was also explained. 0.2 milligram per liter was the amount of residual chlorine required in water. So the next is chlorine demand. Let us see what is chlorine demand. The difference between the quantity applied per liter and the residual is called, the residual chlorine is called the chlorine demand. Let us just take 100 grams is the quantity of chlorine applied per liter. Yeah, I'm just talking about, let us say, I'm not saying anywhere that 100 grams is used per liter. Okay, I'm just explaining you what is chlorine demand. Just take it, 100 grams is applied per liter, and the residual chlorine is 10 grams. Then what is the chlorine demand? It should be 90 grams per liter. So that is the chlorine demand. When that amount of chlorine is used for disinfecting the water, that is called as chlorine demand. Now the next point, polluted water exert more chlorine demand. I mean to say, how much ever the water is polluted, that much chlorine is required, that more amount of chlorine is required for disinfection of water. So more pollution of water means that more chlorine demand. If water is pre-treated by sedimentation and aeration, I have already told you, at the start of the treatment of water, whatever the treatment of water methods, it starts from aeration and sedimentation. If the water is already treated by sedimentation and aeration, chlorine demand obviously will get reduced, because the water is already pre-treated. So the chlorine demand will be reduced. Normally residual chlorine of 0.2 milligram per liter is required. This is the amount what I mentioned priorly. Okay, Then moving on with the next slide, which just tells you about the behavior of chlorine in water. Uh, for us, students of who are studying in diploma, this part of chemistry is bit difficult, but anyway, it is simple to understand. You just look into this. When chlorine is dissolved in water, it forms two kinds of acids. One is hypochlorous acid and another one is hypochloric acid. See, I'm just pointing this one. This is HOCl is hypochlorous acid and HCl is hydrochloric acid. Okay, so Cl2 is chlorine, which is dissolved in H2O water, and the reaction, the arrow mark, whichever I have shown here, it results in HOCl plus HCl. So that is the first reaction. After some time, that is in the same reaction, after some time, hypochlorous acid further ionizes as follows. I mean, just taking one part, okay, HOCl is considered. HOCl further ionizes into, you just see, what is it divided into? H plus OCl. H is positive, OCl is negative. So HOCl is further ionized into H and OCl. This is the second reaction. The two prevailing species, HOCl and OCl, are called free available chlorine, are which are responsible for the disinfection of water. So HOCl and OCl both are responsible for the disinfection of water. Then chlorine reacts with ammonia in water to form, see, there are three types of amines here: monochloramine, dichloramine, and trichloramine. All the chemical formulas are given within the brackets. Just go through. And these three are released, and their distribution depends on the pH value of water. How they are distributed depends on the pH value of water. Let's move on. Or I'll keep this slide for a few more seconds like this, just for your reference, and you can note down the chemical reactions. It is, I think you need to concentrate on this. This is one of the most asked question in the question paper. You just look into this. Behavior of chlorine in water is asked for 5 marks. You can just go through this. Yes, I think we can move to the next slide. Yes, now we'll just talk about the types of chlorination. Types of chlorination, we can just brief it like plain chlorination, super chlorination, and breakpoint dechlorination. Okay, and let us first start with the plain chlorination. Plain chlorination is the process of addition of chlorine only when the surface water with no other treatment is required. Plain chlorination is the simplest type of chlorination when the water does not require any type of any other type of treatment, and then if the chlorine is added, then it is called as plain chlorination. Where it is done, let us see. The water of lakes and springs is pure and can be used after plain chlorination. Whatever, wherever you see some lakes and springs, the water will be pure enough to drink. That is, it could be potable. But just after a simple chlorination method, that is plain chlorination, it could be used as potable water. Next, a rate of now coming to how much should be applied for plain chlorination. A rate of 0.8 milligram per liter per hour at 15 Newton per centimeter square pressure is the normal dosage, so as to maintain a residual chlorine of 0.2 milligram per liter. You just note this. 0.8 milligram per liter per hour is the amount of chlorine used. That is for plain chlorination. At what pressure it needs to be applied? 15 Newton per centimeter square pressure. Then if this amount of chlorine at this pressure which is applied, then it could give a residual chlorine of 0.2 milligram per liter, which is required. Actually recontamination ಆಗದಂಗಿರ್ಲಿ, ವಾಟರ್ ರೀಕಂಟಾಮಿನೇಷನ್ ಆಗೋದನ್ನ ಅವಾಯ್ಡ್ ಮಾಡೋದಕ್ಕೆ ಇಷ್ಟು ರೆಸಿಡ್ಯೂಯಲ್ ಕ್ಲೋರಿನ್ ರಿಕ್ವೈರ್ಡ್ ಇರುತ್ತೆ. Then coming to superchlorination. Superchlorination is defined as administration of a dose considerably in excess of that necessary for the adequate bacterial purification of water. ಅಂದ್ರೆ ಸಿಂಪಲ್ ಟರ್ಮ್ಸ್ ಅಲ್ಲಿ ಹೇಳ್ಬೇಕು ಅಂದ್ರೆ ಎಷ್ಟು ಅಡಿಕ್ವೇಟ್ ಆಗಿ ಅಂದ್ರೆ ಇಷ್ಟು ಸಾಕು ಅಂತಿರುತ್ತೋ ಅದಕ್ಕಿಂತ ಸ್ವಲ್ಪ ಜಾಸ್ತಿ ಡೋಸೇಜ್ ನ ಅಪ್ಲೈ ಮಾಡೋದು, ಅದನ್ನ ಸೂಪರ್ ಕ್ಲೋರಿನೇಷನ್ ಅಂತ ಹೇಳ್ತೀವಿ. ಸಿ ಪ್ರೀವಿಯಸ್ ಏನ್ ಹೇಳಿದೆ, ಪ್ರೀವಿಯಸ್ ಸ್ಲೈಡ್ ಅಲ್ಲಿ ಏನ್ ಹೇಳಿದೆ, ನಾರ್ಮಲ್ ಐ ಮೀನ್ ಪ್ಲೇನ್ ಕ್ಲೋರಿನೇಷನ್ ಅಲ್ಲಿ ಎಷ್ಟು ಹಾಕ್ತಿವಿ, 0.8 milligram per liter ಅಂತ ಹೇಳಿದ್ದೆ. ಈಗ you just look into the superchlorination, the quantity is quite visible. I am showing the pointers here. It is giving as 10 to 15 milligram per liter. I mean to say it is more than 10 times, 10 times more than the plain chlorination. I mean even more. About 10 to 15 milligram per liter is applied with a contact time of 10 to 30 minutes. Okay, contact time is important. As I mentioned in previous slides, it is just like detention period. We can just take it as like a detention period itself. This is called a contact time. How much contact time the water is with the chlorine which is applied. Under the circumstances such as during epidemic breakout, see what we are facing now. We are facing a pandemic, corona, you all know that, right? In such circumstances, we need superchlorination. Okay, during epidemic breakout, water is to be dechlorinated before supply to the distribution system. See, whenever a situation like epidemic or pandemic breakout, whatever, the superchlorination is done and the contact time is given as 10 to 30 minutes. But the water is to be dechlorinated. Water is to be dechlorinated before supply to the distribution system. I mean municipal water supply ಗೆ ಮುಂಚೆ ಅದನ್ನ ಡಿಕ್ಲೋರಿನೇಟ್ ಮಾಡ್ಬಿಡ್ಬೇಕು. ಯಾಕಂದ್ರೆ ಸೂಪರ್ ಕ್ಲೋರಿನೇಟ್ ಮಾಡಿರೋಂಥ ವಾಟರ್ ನ we can't even smell when it is taken near for drinking. So that's why it should be dechlorinated. Next is this breakpoint chlorination. When the chlorine is applied to water containing organic matter, microorganisms, ammonia, the residual chlorine levels fluctuate with increase in dosage as shown in the figure. See, whenever we apply more chlorine to water, the residual chlorine dosage also will be varied. If we apply more chlorine, then the residual chlorine will be also more. So as shown in the figure, the residual chlorine varies. Okay, and this dotted line shows the zero chlorine demand. I mean water is purified in the sense, what is the meaning of that? No chlorine demand. The water doesn't require any amount of chlorine which is used for the disinfection of water. Okay, so and this red line, combined chlorine, it is showing the combined chlorine, and you follow this pointer. I'm showing you at some point of time the chlorine demand, the chlorine applied chlorine is lesser and then it demands more of chlorine. Then what happens, the free free residual chlorine will be more. See, I'm showing the pointer how much it is increased. The residual chlorine amount will be increased so much. Okay, that is this graph which shows the breakpoint chlorination. And the same graph I have taken it to the next slide also, because it would be difficult for you all to follow whichever points I'm just talking about. See, let us see now. Up to the point B. Now I'm showing the pointer here. Up to the point B, it is observed by reducing agents in water like nitrates, iron, etc. Further increases and forms chloramines with ammonia in water. Okay, chloramines ಅಂದ್ರೆ ಏನು ಅಂತ ನೋಡಿ. Chloramines are effective as Cl. Chloramines ನಾನು ಹೇಳಿದ್ದೀನಿ, previous slide ಅಲ್ಲಿ ನಾನು ಅದನ್ನ ಹೇಳಿದ್ದೀನಿ. Chloramines are effective as Cl and OCl formed. When the free chlorine content increases, it reacts with chloramines, reducing the available chlorine. Okay, so yes, you must remember up to the point B, the demand will be less. Chlorine demand will be lesser. And next, at the point D, let us go for the previous slide. Yes, at this point, see the graph. At this point D, all the chloramines are converted to effective N2, N2O and NCl3. Nitrates agi convert agbidutte. So beyond point D, free residual chlorine appear again. This point D is called as breakpoint chlorination. Dosage beyond this point is same as superchlorination. ನೋಡಿ, ಬ್ರೇಕ್ ಪಾಯಿಂಟ್ ಕ್ಲೋರಿನೇಷನ್ ಅಂದ್ರೆ ಅಲ್ಲಿವರೆಗೂ ಕ್ಲೋರಿನ್ ಡಿಮ್ಯಾಂಡ್ ಇರುತ್ತೆ, ಅದಾದ್ಮೇಲೆ ಫ್ರೀ ರೆಸಿಡ್ಯೂಯಲ್ ಕ್ಲೋರಿನ್ ಆಗಿ ಅದು ಅಪಿಯರ್ ಆಗುತ್ತೆ. ಅಂದ್ರೆ ಅದಾದ್ಮೇಲೂ ನಾವು ಕ್ಲೋರಿನೇಷನ್ ಮಾಡ್ತಾ ಹೋದ್ರೆ ಅದನ್ನ ಸೂಪರ್ ಕ್ಲೋರಿನೇಷನ್ ಅಂತ ಕರಿತೀವಿ. ಇನ್ ಸೂಪರ್ ಕ್ಲೋರಿನೇಷನ್ ನೋ ಸಚ್ ರ್ಯಾಷನಲ್ ಮೆಜರ್ಮೆಂಟ್ ಇಸ್ ಮೇಡ್. ಇಷ್ಟೇ ಡೋಸೇಜ್ ಹಾಕ್ಬೇಕು. ನಾನು ಆಗ್ಲೇ ಹೇಳದ್ನಲ್ಲ, ಪ್ಲೇನ್ ಕ್ಲೋರಿನೇಷನ್ ಅಲ್ಲಿ ಎಷ್ಟು ಡೋಸೇಜ್ ಕೊಡ್ತಾ ಇದೀವಿ, 0.8 milligram per liter per hour ಅಂತ ಹೇಳಿದೆ. In super chlorination, it went up to 10 to 15 milligram per liter. So beyond this point D, it is as same as super chlorination. There is no such rational measurement. Just the dosage is taken as very much random. ಎಷ್ಟಾದ್ರೂ. Then we spoke about plain chlorination, super chlorination, breakpoint chlorination. Now coming to the last one, dechlorination. I have spoke about this term also. Dechlorination ಅನ್ನೋದ್ರ ಬಗ್ಗೆ ಹೇಳಿದೀನಿ, ಬ್ರೇಕ್ ಪಾಯಿಂಟ್ ಕ್ಲೋರಿನೇಷನ್ ಅಲ್ಲೇನೆ ಹೇಳಿದೀನಿ. ಏನಿದು ಡಿಕ್ಲೋರಿನೇಷನ್ ಅಂತಂದ್ರೆ, ಎಕ್ಸೆಸ್ ಏನ್ ಕ್ಲೋರಿನೇಷನ್ ನಾವು ಪ್ರೊವೈಡ್ ಮಾಡಿರ್ತೀವಿ, ಕ್ಲೋರಿನ್ ನ ಪ್ರೊವೈಡ್ ಮಾಡಿರ್ತೀವಿ ಸೂಪರ್ ಕ್ಲೋರಿನೇಷನ್ ಅಲ್ಲಿ, ಅದನ್ನ ಕಂಪ್ಲೀಟ್ ಆಗಿ ರಿಮೂವ್ ಮಾಡೋದನ್ನ ನಾವೇನಂತ ಹೇಳ್ತೀವಿ, ಡಿಕ್ಲೋರಿನೇಷನ್ ಅಂತ ಹೇಳ್ತೀವಿ. See the definition. Removal of excess chlorine resulting from superchlorination in part or completely, it is known as dechlorination. Excess chlorine in water gives pungent smell and corrode the pipelines. Hence excess chlorine is to be removed before supply. ನಾನು ಇದನ್ನ ಹೇಳಿದೀನಿ, ಕೆಲವು ಕಡೆ ಪಬ್ಲಿಕ್ ಎಲ್ಲಿ ಜಾಸ್ತಿ ದೇವಸ್ಥಾನಗಳು ಅಥವಾ ಬೇರೆವರ್ ವಿ ಗೋ ಇನ್ ಅ ಮಾಸ್ ಎಲ್ಲಿರ್ತಾರೆ ಅಲ್ಲಿ ನೀರು ಪಬ್ಲಿಕ್ ವಾಟರ್ ನ ತಗೊಂಡು ಸ್ಮೆಲ್ ಮಾಡಿ ನೋಡಿ, ಇಟ್ ಡೆಫಿನೆಟ್ಲಿ ಗಿವ್ಸ್ ಅ ಕ್ಲೋರಿನ್ ಸ್ಮೆಲ್. ದೇ ವಿಲ್ ಗೋ ಫಾರ್ ಸೂಪರ್ ಕ್ಲೋರಿನೇಷನ್ random. That's why it gives a pungent smell. It is really hard to drink the water, and it corrode the pipelines also. And hence the excess chlorine has to be removed before the supply to the municipal water lines. Okay, then the physical methods like aeration, heating and absorption on charcoal may be adopted. ನೋಡಿ, ಮತ್ತೆ ಇವಾಗ ಸೂಪರ್ ಕ್ಲೋರಿನೇಷನ್ ಮಾಡ್ಬಿಡ್ತೀವಿ ಯಾವ್ದೋ ಕಾರಣಕ್ಕಿರ್ಬೋದು, ಲೈಕ್ ದಿಸ್ ಎಪಿಡೆಮಿಕ್, ಸಮ್ ಬ್ರೇಕ್ ಡೌನ್ ಆಫ್ ದ ಎಪಿಡೆಮಿಕ್, ಪ್ಯಾಂಡಮಿಕ್, ಫಾರ್ ವಾಟ್ ಎವರ್ we go for super chlorination, then it has to be dechlorinated. For the dechlorination, see the methods. Physical methods like aeration, heating, absorption on charcoal, these are all the methods which are adopted for dechlorination. Okay. Then chemical methods like sulfur dioxide, sodium bisulfate, sodium thiosulfite are also used. Andre ಒಂದು physical method ಅಲ್ಲಿ aeration ಓದಿದ್ದೀರಾ ನೀವು, sedimentation ಮುಂಚೆ aeration ಓದಿದ್ದೀರಾ, ಅದ್ ಒಂದು ಮೆಥಡ್, ಹೀಟಿಂಗ್ ಒಂದ್ ಮೆಥಡ್, ಅಬ್ಸಾರ್ಪ್ಷನ್ ಆನ್ ಚಾರ್ಕೋಲ್, ಇವೆಲ್ಲ ಫಿಸಿಕಲ್ ಮೆಥಡ್ಸ್ ಆಯ್ತು. ಯಾವುದಕ್ಕೆ? ಕ್ಲೋರಿನ್ ನ ರಿಮೂವ್ ಮಾಡಕ್ಕೆ, ಡಿಕ್ಲೋರಿನೇಷನ್ಗೆ. ನೆಕ್ಸ್ಟ್ ಕಮಿಂಗ್ ಟು ಕೆಮಿಕಲ್ ಮೆಥಡ್ಸ್, ದೇರ್ ಆರ್ 3. ಸಲ್ಫರ್ ಡೈಆಕ್ಸೈಡ್ ನ ಆಡ್ ಮಾಡಬಹುದು, ಸೋಡಿಯಂ ಬೈಸಲ್ಫೇಟ್ ಅಥವಾ ಸೋಡಿಯಂ ಥಿಯೋಸಲ್ಫೇಟ್ ನ ಆಡ್ ಮಾಡಬಹುದು. ದೀಸ್ ಆರ್ ದ ಕೆಮಿಕಲ್ ಮೆಥಡ್ಸ್ ಯೂಸ್ಡ್ ಫಾರ್ ಡಿಕ್ಲೋರಿನೇಷನ್. ನೆಕ್ಸ್ಟ್, now till now we just noted about types of chlorination. Now we are going to study about the points of chlorination. Points of chlorination ಅಂದ್ರೆ ಎಲ್ಲಿ ಯಾವ ಸ್ಟೇಜ್ ಅಲ್ಲಿ ನಾವು ಕ್ಲೋರಿನ್ ನ ಅಪ್ಲೈ ಮಾಡ್ತಾ ಇದೀವಿ ಅನ್ನೋದನ್ನ ಪಾಯಿಂಟ್ಸ್ ಆಫ್ ಕ್ಲೋರಿನೇಷನ್ ಅಂತ ಹೇಳ್ತೀವಿ. Now let us see at what points we are going to add chlorine and at what amount we are going to add chlorine. Chlorine applied at various stages of treatment and distribution. Accordingly, they are known as pre, post and rechlorination. ಅಂದ್ರೆ ಅದರಲ್ಲಿ ಪಾಯಿಂಟ್ಸ್ ಅಲ್ಲಿ 3 ತರ ಇದೆ. ಯಾವ್ಯಾವ ಸ್ಟೇಜ್ ಅಲ್ಲಿ ಅಪ್ಲೈ ಮಾಡ್ತೀವಿ ಅನ್ನೋದು 3 ತರ ಇದೆ. ಒಂದು ಪ್ರೀ ಕ್ಲೋರಿನೇಷನ್, another one is post chlorination, then the last one is rechlorination. Okay, and you should not confuse the terms. Dechlorination ne bere, rechlorination ne bere. Okay, there are two different terms. Don't get confused with that. Okay, previously while I was explaining dechlorination, it was types of chlorination, not points of chlorination. Please note down. Okay, that was types of chlorination and this is points of chlorination. Yes, coming to pre-chlorination. Chlorine applied prior to the sedimentation and filtration process is known as pre-chlorination. Yeah. Chlorine which is applied, I was about to tell you this one. Before sedimentation also sometimes there will be need to apply chlorine, and before the filtration process also. If the chlorine is applied at that time, then it is known as pre-chlorination. Okay, I mean to say it is the initial stages of water treatment. At that time, if you are using chlorine, then it is called as pre-chlorination. This is practiced when the water is heavily polluted and to remove taste, odor, color and growth of algae in treatment units. ನೋಡಿ, ಟ್ರೀಟ್ಮೆಂಟ್ ಯೂನಿಟ್ಸ್ ಅಲ್ಲಿ ತುಂಬಾ ಸೆಡಿಮೆಂಟ್ಸ್ ಎಲ್ಲ ತುಂಬಾ ಪೊಲ್ಯೂಷನ್ ಆಗಿದ್ರೆ ಸೆಡಿಮೆಂಟ್ಸ್ ಎಲ್ಲ ಜಾಸ್ತಿ ಇರುತ್ತೆ, ಆಮೇಲೆ ಗ್ರೋತ್ ಆಫ್ ಆಲ್ಗೆ ಜಾಸ್ತಿ ಇರುತ್ತೆ, ಪಂಜೆಂಟ್ ಓಡರ್ ಇರುತ್ತೆ, ಐ ಮೀನ್ ಕಲರು ಟರ್ಬಿಡ್ ಆಗಿರುತ್ತೆ. ಸೊ ಇದನ್ನೆಲ್ಲ ನೋಡಿದಾಗ ಕ್ಲೋರಿನೇಷನ್ ರಿಕ್ವೈರ್ಡ್ ಅಂತ ಅನ್ಸಿದ್ರೆ ಟ್ರೀಟ್ಮೆಂಟ್ ಯೂನಿಟ್ಸ್ ಅನ್ನ ಅಲ್ಲೇನೆ ಜಾಸ್ತಿ ಪೊಲ್ಯೂಷನ್ ಆಗಿದೆ ಅಂತ ಅನ್ಸಿದ್ರೆ ಪ್ರೀ ಕ್ಲೋರಿನೇಷನ್ಗೆ ಆಪ್ಟ್ ಮಾಡ್ಕೊಳ್ತಾರೆ. ಪ್ರೀ ಕ್ಲೋರಿನೇಷನ್ ಇಂಪ್ರೂವ್ಸ್ ಕೋಆಗುಲೇಷನ್ ಅಂಡ್ ಪೋಸ್ಟ್ ಕ್ಲೋರಿನೇಷನ್ ಡೋಸೇಜ್ ಮೇ ಬಿ ರೆಡ್ಯೂಸ್ಡ್. ಈ ಪ್ರೀ ಕ್ಲೋರಿನೇಷನ್ ಕೋಆಗುಲೇಷನ್ ಪ್ರೋಸೆಸ್ ನ ಇಂಪ್ರೂವ್ ಮಾಡುತ್ತೆ, ಆಸ್ ವೆಲ್ ಆಸ್ ಪೋಸ್ಟ್ ಕ್ಲೋರಿನೇಷನ್ ನಲ್ಲಿ ಎಷ್ಟು ಡೋಸೇಜ್ ಬೇಕಾಗಿರುತ್ತೆ ಅದನ್ನ reduce ಮಾಡುತ್ತೆ. Next, coming to the other 2 points, that is post chlorination and then rechlorination. Post chlorination andre nodona, when the chlorine is added in the water when the chlorine is added in the water after all the treatments, then it is known as post chlorination. ಎಲ್ಲಾ ಟ್ರೀಟ್ಮೆಂಟ್ ಗಳು ಮುಗ್ದೋಯ್ತು, ಅದಾದ್ಮೇಲೆ ಕ್ಲೋರಿನ್ ಆಡ್ ಮಾಡಿದ್ರೆ ಅದನ್ನ post chlorination ಅಂತ ಹೇಳ್ತಾರೆ. Okay, then why is it needed ಅಂದ್ರೆ that's what I have told you. It is a good disinfectant. It can kills the pathogenic bacteria. All the process I have spoken too long about the chlorination itself. Then coming to rechlorination. In long distribution systems, chlorine residues may leave the water ಅನ್ಸೇಫ್ ಅಂದ್ರೆ ಡಿಸ್ಟ್ರಿಬ್ಯೂಷನ್ ಮೇನ್ಸ್ ಇಂದ ಸಪ್ಲೈ ಮೇನ್ಸ್ ಬಂದು ಈ ತರ ಎಲ್ಲ ಲಾಂಗ್ ಡಿಸ್ಟ್ರಿಬ್ಯೂಷನ್ ಸಿಸ್ಟಮ್ ಆಗಿದ್ರೆ ಕ್ಲೋರಿನ್ ರೆಸಿಡ್ಯೂಸ್ ತುಂಬಾ ವಾಟರ್ ನ ಅನ್ಸೇಫ್ ಮಾಡ್ಬಿಡುತ್ತೆ. ಅಪ್ಲಿಕೇಶನ್ ಆಫ್ ಎಕ್ಸೆಸ್ ಕ್ಲೋರಿನ್ ಟು ಕಂಪನ್ಸೇಟ್ ಫಾರ್ ದಿಸ್ may lead to unpleasant smell to consumers at the points nearer to the treatment point. ಎಲ್ಲಿ ಟ್ರೀಟ್ಮೆಂಟ್ ಪಾಯಿಂಟ್ ಇರುತ್ತೋ ಅಲ್ಲಿ ಯಾರು ವಾಸ ಆಗಿರ್ತಾರೋ ಅವ್ರಿಗೆ ತುಂಬಾ ಅನ್ಪ್ಲೆಸೆಂಟ್ ಸ್ಮೆಲ್ ಬರ್ತಾ ಇರುತ್ತೆ ಕ್ಲೋರಿನೇಷನ್ ಆಗಿರೋದ್ರಿಂದ, ಕ್ಲೋರಿನೇಷನ್ ಮಾಡೋದ್ರಿಂದ. ಇನ್ ಸಚ್ ಕೇಸಸ್ ಕ್ಲೋರಿನ್ ಇಸ್ ಅಪ್ಲೈಡ್ ಅಗೇನ್, that is rechlorinated at intermediate points, generally at service reservoirs and booster pumping station. ಅದಕ್ಕೆ ಏನ್ ಮಾಡ್ತಾರೆ, ರೀಕ್ಲೋರಿನೇಟ್ ಮಾಡ್ಕೊಂಡು ಎಕ್ಸೆಸ್ ಪೊಲ್ಯೂಟೆಡ್ ವಾಟರ್ ನ ಈ ತರ ಕ್ಲೋರಿನೇಟ್ ಮಾಡ್ಕೊಂಡು ಇಂಟರ್ಮೀಡಿಯೇಟ್ ಪಾಯಿಂಟ್ಸ್ ಅಲ್ಲಿ ಸರ್ವಿಸ್ ರಿಸರ್ವಾಯರ್ಸ್ ಅಂದ್ರೆ ಇವಾಗ ಯಾವ್ದೋ ಒಂದು ರಿಸರ್ವಾಯರ್ ಇರುತ್ತೆ, ಅಲ್ಲಿಂದ ಇನ್ನೊಂದ್ ಕಡೆಗೆ ವಾಟರ್ ನ ಹಾಕೊಳ್ತಾರಲ್ಲ, ಅಲ್ಲಿಂದ ಮತ್ತೆ ಮೇನ್ ಸಪ್ಲೈ ಲೈನ್ಸ್ ಹೋಗುತ್ತಲ್ಲ, ಅದನ್ನ ಸರ್ವಿಸ್ ರಿಸರ್ವಾಯರ್ಸ್ ಅಂತ ಹೇಳ್ತಾರೆ. ಓಕೆ, ಅಂಡ್ ಬೂಸ್ಟರ್ ಅಲ್ಲಿಂದ ಪಂಪಿಂಗ್ ಸ್ಟೇಷನ್ಗೆ ಕಳಿಸ್ತಾರಲ್ಲ, ಅಲ್ಲಿ ಮತ್ತೆ ರೀಕ್ಲೋರಿನೇಟ್ ಮಾಡ್ಕೊಳ್ತಾರೆ. Okay, so this is known as rechlorination. So I'll just brief about whatever we have studied in this session number 28. What did we study today? I just spoke about the chlorination. Chlorination previous class alli odidvi, and now we just briefed about ರೆಸಿಡ್ಯೂಯಲ್ ಕ್ಲೋರಿನ್ ಅಂಡ್ ಕ್ಲೋರಿನ್ ಡಿಮ್ಯಾಂಡ್ ಬಗ್ಗೆ ಓದಿದ್ವಿ. ರೆಸಿಡ್ಯೂಯಲ್ ಕ್ಲೋರಿನ್ ಅಂದ್ರೆ ನಾನು ಪ್ರೀವಿಯಸ್ ಕ್ಲಾಸ್ ಅಲ್ಲೂ ಹೇಳಿದ್ದೆ ಮತ್ತೆ ಈ ಕ್ಲಾಸ್ ಅಲ್ಲೂ ಹೇಳಿದ್ದೆ. ರೆಸಿಡ್ಯೂಯಲ್ ಕ್ಲೋರಿನ್ ಶುಡ್ ಬಿ ದೇರ್ ಫಾರ್ avoiding the recontamination of water, and the quantity should be up to 0.2 milligram per liter. That is the quantity usually the residual chlorine should be. And then behavior of chlorine, ಕೆಲವು ಕೆಮಿಕಲ್ ರಿಯಾಕ್ಷನ್ಸ್ ಇಂದ ಹೈಪೋಕ್ಲೋರಸ್ ಆಸಿಡ್ ಮತ್ತೆ ಹೈಡ್ರೋಕ್ಲೋರಿಕ್ ಆಸಿಡ್ ಆಗುತ್ತೆ, ಅದು ಫರ್ದರ್ ಅಯೋನೈಸ್ ಆಗುತ್ತೆ. ಹೌ ದ HOCl and OCl are free available chlorine and are responsible for disinfection of water ಅಂತ ಹೇಳಿದೀನಿ. So this is all, I mean it reacts with ammonia. All these points I have spoken about, and I have told in detail about the types of chlorination. One is plain chlorination, another one is super chlorination, then is breakpoint chlorination, then is dechlorination. So all these are types of chlorination I have spoken about. And do not, again and again I'm stressing on some particular point, that you should not get confused with dechlorination and rechlorination. Dechlorination is a type of chlorination wherein you remove the excess chlorine, which is excessive, added in excess in superchlorination. Okay, removal is called as dechlorination. Rechlorination ಅಂತಂದ್ರೆ ಮತ್ತೆ ಬರ್ತೀನಿ, ಇದು ಪಾಯಿಂಟ್ಸ್ ಆಫ್ ಕ್ಲೋರಿನೇಷನ್ ಅಲ್ಲಿ ಬರುತ್ತೆ. ರೀಕ್ಲೋರಿನೇಷನ್ ಅಂದ್ರೆ ಮತ್ತೆ ಕ್ಲೋರಿನ್ ಆಡ್ ಮಾಡೋದನ್ನ ರೀಕ್ಲೋರಿನೇಷನ್ ಅಂತ ಹೇಳ್ತೀವಿ. This is points of chlorination. Okay, points of chlorination ಅಲ್ಲಿ 3 ಪಾಯಿಂಟ್ ನಾವು ನೋಡ್ಬೋದು. ಒಂದು ಪ್ರೀ ಕ್ಲೋರಿನೇಷನ್, ಎಲ್ಲಾ ಟ್ರೀಟ್ಮೆಂಟ್ ಗಿಂತ ಮೊದಲು ನಾವು ಕ್ಲೋರಿನ್ ನ ಆಡ್ ಮಾಡಿದ್ರೆ ಅದನ್ನ ಪ್ರೀ ಕ್ಲೋರಿನೇಷನ್ ಅಂತ ಹೇಳ್ತೀವಿ. ನೆಕ್ಸ್ಟ್ ಪೋಸ್ಟ್ ಕ್ಲೋರಿನೇಷನ್, ಎಲ್ಲಾ ಟ್ರೀಟ್ಮೆಂಟ್ ಮುಗಿದ ಆದ್ಮೇಲೆ ಕ್ಲೋರಿನ್ ಆಡ್ ಮಾಡಿದ್ರೆ ಅದನ್ನ ಪೋಸ್ಟ್ ಕ್ಲೋರಿನೇಷನ್ ಅಂತ ಹೇಳ್ತೀವಿ. ರೀಕ್ಲೋರಿನೇಷನ್ ಅಂತ ಅಂದ್ರೆ ಲಾಂಗ್ ಡಿಸ್ಟ್ರಿಬ್ಯೂಷನ್ ಸಿಸ್ಟಮ್ಸ್ ಅಲ್ಲಿ ಕ್ಲೋರಿನ್ ರೆಸಿಡ್ಯೂಸ್ ಇಂದ ಎಲ್ಲಿ ನಮ್ಗೆ ವಾಟರ್ ಅನ್ಸೇಫ್ ಅನ್ನಿಸ್ತಾ ಇರುತ್ತೆ, ಆ ತರ ಇದ್ದಾಗ ಏನ್ ಮಾಡ್ತೀವಿ, ಇಂಟರ್ಮೀಡಿಯೇಟ್ ಸಿಸ್ಟಮ್ಸ್ ಮಾಡ್ಕೊಳ್ತೀವಿ. ಲೈಕ್ ಸರ್ವಿಸ್ ರಿಸರ್ವಾಯರ್ಸ್, ಬೂಸ್ಟರ್ ಪಂಪಿಂಗ್ ಸಿಸ್ಟಮ್ಸ್ ಅಲ್ಲಿ ಮತ್ತೆ ಕ್ಲೋರಿನ್ ಆಡ್ ಮಾಡ್ಕೊಳ್ತೀವಿ. ಅಂದ್ರೆ ನಾಟ್ ಆಡಿಂಗ್ ಕ್ಲೋರಿನ್ ಅಟ್ ಅ ಟೈಮ್, ಜಸ್ಟ್ ಲೈಕ್ ಸೂಪರ್ ಕ್ಲೋರಿನೇಷನ್, ದೇ ವಿಲ್ ಮೇಕ್ ದ ಕ್ಲೋರಿನ್ ಇಂಟರ್ಮೀಡಿಯೇಟ್ ಆಗಿ ಅದನ್ನ ಆಡ್ ಮಾಡೋದಕ್ಕೆ ಏನ್ ಮಾಡ್ಕೊಳ್ತೀವಿ, ಮತ್ತೆ ಆಡ್ ಮಾಡೋದನ್ನ ರೀಕ್ಲೋರಿನೇಷನ್ ಅಂತ ಹೇಳ್ತೀವಿ. So this is all about the topics we studied in session number 28. Now coming to As you all know, multiple choice questions na ಯಾಕೆ ಆಡ್ ಮಾಡ್ತೀವಿ ಅಂತಂದ್ರೆ, we usually want to know the response of the class. ಏನು ಇಷ್ಟೊತ್ತು ಏನು ಓದಿದ್ರಿ ನೀವು, ಅದು ನಿಮ್ಗೆ ಅರ್ಥ ಆಗಿದೆಯಾ ಇಲ್ವಾ ಅಂತ ಚೆಕ್ ಮಾಡೋದಕ್ಕೆ ಚಿಕ್ಕದಾಗಿ ಕ್ವೆಶನ್ ಅಂಡ್ ಆನ್ಸರ್ ಸೆಷನ್ಸ್ ಇರುತ್ತೆ. ನಾವು ಯು ಮಸ್ಟ್ ಜಸ್ಟ್ ಟೆಲ್ ಮಿ. Let me see. Let me just check this one. The process of killing all pathogenic bacteria of waterborne diseases to make it safe for hospital use is called as. Yes, I know, I can guess. As this is the chapter of chlorination, your answer will be chlorination, right? But it is wrong. Actually, for stressing, the point to be stressed is it is safe for hospital use. So the answer is sterilization. Next, pre-chlorination. ನೋಡಿ, pre-chlorination ಅಂದ್ರೆ ಡೆಫಿನೇಷನ್ ತರ ಹೇಳಿದ್ದಾರೆ ಅವರು. Pre-chlorination, A, improves coagulation, B, reduces odor, next reduces the taste. Actually, what should be the answer? It reduces the odor? Yes, all of the above is right. So answer for this question is D, all of above. Next, which of the following chemical is sometime added in the process of coagulation and flocculation? ಯಾವ chemical ನ add ಮಾಡ್ತೀವಿ coagulation ಮತ್ತೆ flocculation ಅಲ್ಲಿ ಅಂತ ಹೇಳ್ತಾರೆ. ಯಾವ್ದು add ಮಾಡ್ತೀವಿ? It is calcium chloride. Usually chlorides na use ಮಾಡ್ತೀವಿ coagulation ಮತ್ತೆ flocculation ಅಲ್ಲಿ. Actually, this question is bit irrelevant for this topic, but I think you people must answer because you have studied the coagulation and flocculation in the earlier classes prior to the classes of 25, session number 25. So you need to answer this. So this question, alum increases. What does it increase? Alum, you know, aluminum sulfate. Okay, it increases. What does it increase? Hardness of water, carbonates of water, and then sulfate in water, then acidity of water. The answer must be sulfate in water. You know why? The alum itself is a sulfate, so it increases the sulfate in water. Yes, the common methods for disinfection in wastewater treatment plants are chlorination, UV light, wastewater. Yeah, this is, I think the question should be water treatment plants. Okay, we'll take it as water treatment plants. A, chlorination. B, UV light. UV is ultraviolet light. Both A and B. Phenolic solvent. So we know that disinfection of water anatopically, chlorination ಓದಿದ್ದೀವಿ, UV light ಬಗ್ಗೆನೂ ಓದಿದ್ದೀವಿ, ultraviolet rays ಬಗ್ಗೆ ಓದಿದ್ದೀವಿ. That is one of the chemical treatment. So we can take this as, I mean, one is chemical treatment, another one is physical treatment. So both are common methods which are used for the disinfection of water. So the answer is C, both A and B. Next, hypochlorous acid is dash times effective as hypochlorite ions. So this is a bit difficult question, but I could see this question in one of the DCET papers. That's why I have picked difficult questions. ಯಾಕೆ question ಯಾಕೆ ಅಂತಂದ್ರೆ, ಯೂಶಲಿ ನಾವು ಕೆಮಿಸ್ಟ್ರಿನ ಓದಿರಲ್ಲ. We have studied just physics in the diploma classes, so it might be difficult for you to answer this one. The answer is D, 80 times effective than the hypochlorite ions anta heltare. Yes. Next one, chlorine, which gets consumed in the oxidation of impurities before disinfection. Oxidation of impurities andre ಏನು? Before disinfection, ಅದನ್ನ ಏನಂತ ಕರೀತಾರೆ? ಎಷ್ಟು ಬೇಕಾಗುತ್ತೆ ಕ್ಲೋರಿನ್ ಅಂತ. So that is called as chlorine demand. Okay. Yes, this is these are the 1 mark questions. What is residual chlorine? What is chlorine demand? We can go back to the first slide just to note what is residual chlorine. Okay, residual chlorine ಅಂದ್ರೇನು? ಎಷ್ಟು ಕ್ಲೋರಿನ್ ಉಳಿದಿರುತ್ತೆ for the recontamination, to avoid the recontamination of water. That is called as residual chlorine. The quantity, as I've already repeated many times, the quantity is 0.2 milligram per liter. Okay, so that is residual chlorine. And what is chlorine demand? Chlorine demand helidini. What is that? The difference between whatever chlorine which is applied, okay, and the residual chlorine. The difference between the both is known as chlorine demand. And name the types of chlorination. Yeah, types of chlorination, you can just tell it as yeah, plain chlorination, super chlorination, breakpoint chlorination, and dechlorination. These are the types of chlorination. And coming to the next question, chlorine applied prior to the sedimentation and filtration process is known as. ಇದನ್ನ just now ನಾನು explain ಮಾಡಿದೆ while explaining the points of chlorination. When it is applied prior ಅಂದ್ರೆ ಮುಂಚೆ ಮೊದಲು sedimentation and filtration ಗೆ ಮೊದಲು ಅಪ್ಲೈ ಮಾಡಿದ್ರೆ ಅದನ್ನ pre-chlorination ಅಂತ ಕರಿತೀವಿ. Next, when the chlorine is added in water after all the treatment, then it is known as, what is it known as? Yes, it is post chlorination. So I hope the students who are online were also able to answer all these questions. So this was the class of chlorination. In the next class, I'm going to talk about the dosage of chlorine as well as dosage of bleaching powder which is used in the treatment of water. And I'll come up with some of the problems of dosage of chlorine, dosage of bleaching powder, and one of the problems of dosage of alum. So this was the class, this was the session 28, which dealt with the chlorination, residual chlorine and chlorine demand, types of chlorination, reactions of chlorination, then types ಆಯ್ತು, points of chlorination, and lastly with the multiple choice questions. So I hope the class will the students will recall all these points until we come up with the next session, that is session number 29. Just now I told you I'll deal with some of the problems regarding the same. Okay, the dosage of chlorine and bleaching powder and dosage of alum. That's it. That's all for the class.